Welcome back to our channel. We're back again with our quantum reinforced knowledge distillation for Fantasy Premier League player performance estimation. This week we've come up with a name for it. For now, we would like to call it Fantasy Forge. So today we're going to give you our business pitch on why you should care about our project. So we're going to start off with the problem statement. So our problem statement, we're talking about basically how in Uganda, over 11 million managers are playing Fantasy Premier League. And up to this point, there has yet to be a Ugandan winner to win and maybe go to the Premier League and a chance to watch their favorite teams play. The best that has happened is maybe winning their individual leagues with their friends and all that. So for us, that's the problem statement. And to overcome it, that's where our project comes in with being able to accurately predict players' performances and be able to help the Ugandan managers right now be able to compete with the other managers abroad. So, which leads us to our project objectives, which number one is accurate player point prediction, predict FPL points for players in upcoming game weeks as accurately as possible, which will give you an edge in getting higher points, overall points, and help managers go higher and higher on the leaderboard. Optimize team selection. Here, as our demo previously showed, it gives different squads and players you can select so that you can have a better chance of competing based off our algorithm in predicting how well players will perform, or even if they don't perform well that game week, in the next 5 game weeks, they are assured of having a high input. Dynamic model updates such as being adept to real-time changes, continuously update predictions with new data. So there, in this case, is if a player gets injured who was maybe in your team, being able to alert you and inform you that you can no longer select this player, or you should remove them, or you should replace them by buying a different player because they are either injured, they have been suspended, or they can't play against a specific club if they are a loaned player, stuff like that. And then the final thing is to be integrated into the FPL API so that it's easier for us to recommend transfers, suggest any changes to your teams, and it's easier to predict. Yeah, that's basically our project objectives. So our solution overview is, first of all, our model that we trained and used was the XGBoost model. So the XGBoost model, what it does is that it trains data in different phases. So, for example, it first makes different trees, learning trees. So what it will do is it will learn from its first training or teaching process, get the results from that teaching process, send it down to the next training learning tree, and that learning tree will learn from the previous tree's errors and the training it underwent, and then it would carry out its own training and then send it down to the next tree, and it will learn from all their previous errors and previous training, and then at the end of it all give you a prediction. So this approach, it it enables our algorithm be able to predict or like suggest players within the budget and give you a great chance of doing well that game week. So that's basically how our algorithm works. So the data we used, first of all, we got it from a GitHub repository of Vastav. And also we added on by getting some more data from the official Fantasy Premier League API, and we were able to add it onto our data set, which consists of 756 different players and 19 features or columns. So they consist of the stuff shown before: goals scored, assists, and etc. That's basically our data. And the models, I'll allow my colleague to take us through the different models and techniques. Thank you.
Yes, thank you. And I'm going to proceed by explaining how we trained our models, the performance, and what we achieved. So to begin with, we trained 10 models, and this include traditional machine learning models like XGBoost, support vector machines, logistic regression, and we also managed to use some emerging techniques like quantum machine learning and deep learning. And these models had a performance as you see in the table. And the best performing model was the XGBoost, which was able to classify better whether a player was a high performer or low performer based on the precision and recall. So this project was obviously the aim was to use quantum machine learning, but due to resource constraints and yeah, computing power, it underperformed and was the worst performing model with an accuracy of 0.2 or 20%, and it wasn't able to classify very well whether a player was a high performer or low performer with a precision of 0.2. Yeah, so we went ahead and created a system architecture, which is just the flow of our implementation of the project, and obviously starts with processing data, then passes through the models, our training model, which is the XGBoost. Then, since this is real-time processing, because performance of a player on a previous game week may be different from a next game week, so the model keeps on training and comes up with evaluation and comes up with a team. And we implemented this using libraries like Panda for data collection and pre-processing. We trained a model using XGBoost and PyTorch. To achieve the accuracy of 98, we optimized the hyperparameters of the models using Optuna, and we evaluated the precision, accuracy, and other matrices using libraries like scikit-learn, and we also deployed our model on AWS, and also the API was created using Flask, which is a framework used for developing the API. Then these are the results for the models. As I said before, XGBoost was the best performing, and also we had some good performing models like the deep learning model, but it had a poor precision. So basically, the graphs here, to begin with the feature importance graph, it shows that the features that influenced the models the most were the bonus point system and the ICT index. Minutes and influence are the ones that determine most whether a player is a high performer or low performer. And down here, we have a graph that shows how the BPS, the bonus point system, varied among different players. So these plots show different players, over 700 and I think 52 players. And we see that most of them, their bonus system starts from around 1.5, and therefore has a accuracy for a game for predicting whether a player is a high performer based on the BPS. So we expect this project to impact Ugandans since there is a growing interaction with the game worldwide, including Uganda. So we expect this project to be a stepping stone for various industries, including data science and maybe other sports analytics like cricket, tennis, and other projects that include sports analytics. So for the substantial development goals, like the SDG for education, we expect maybe this to be a stepping stone in education and other students that want projects in and want projects that deal with sports analytics. We also expect this to create some jobs. Like we can create a team where people can do the model training and monitor the player data and make sure the API works. So SDG 8 can help us work with that, and SDG 12 can help us improve the FPL industry. by creating substantial consumption and production of our APIs. And the intellectual property rights, since our models are mathematical, we can't put patent rights on mathematics, but we can put patent rights on how we developed the model, the training process, and the API. And we can also copyright the user interface, our website. Now, of course, the code, the ADA we developed. Now we can also put a trademark on our brand, the logos, the domain names, everything we used. We can put rights on them, and we can also put rates on the platform we used. So our monetization and scaling, we expect the price for this to be in a range of $5 to $10, which is around 15 to 30, 40K around there. And also the API access, the premium, which is the very, very accurate teams. Then we also expect to have an affiliate model like referrals. Then the scaling, we can expect scaling to be achieved through like putting this project on various platforms, and other fantasy sports leagues and other people involved in other sports can use the API or customize it for their project, like cricket, tennis, all sports that need analytics. So this was our system demonstration. So it has two implementations. An FPO manager can either choose a player by filling in the form and submitting to get the points that player could get, or select from the various teams we produce using our model. Basically, we produce 5 teams, and these teams have different players in positions. So as you can see, we chose 2 teams with different goalkeepers. These are the teams that were returned. We have Sales and Rare of Arsenal. So most managers wouldn't have chosen Sales because maybe it's not from a big team, but due to the constraints of the price or the form, they can choose to go with Sales and maybe do opportunity cost and sacrifice maybe a striker. So these are 2 different teams with multiple players in defense, midfield, and forward. So a player can choose to select a team or select a player by filling in the form. So these are team contributions. We both contributed to EDA. My colleague did the API development. We made sure the concept paper was up to date. So the lesson we learned is that the data set being small, it can lead to poor generalization and classification. Since multiple models had a problem of classification, if a model has multiple features, maybe overfitting can be eliminated and the model can perform well. Then we also learned that there is an importance of real-time data, since figures from a previous game week can be different from the next game week. So we need real-time processing of player information such that we come up with more accurate predictions based on the real-time data. And our future work would based on implementing quantum machine learning by maybe increasing the computing power and gaining more computing resources, since it was a limitation for this project. Maybe in the near future we could leverage the technology. And in conclusion, we see that traditional models had better performance than emerging technologies like quantum machine learning, by DexDCBoost achieving an accuracy of 98%, while the quantum model achieved 28% accuracy. And therefore, this study highlights the potential of these models in sports analytics. So that was our presentation and how we we can monetize the project and develop it better. Thank you.